Hello and welcome everyone to the Intrepid Museum's live virtual programming. Thanks so much for joining us today for our program Biome Away from Home. My name's Elysia and I'm an educator at the Intrepid Sea, Air and Space Museum here in New York City. I'll be your host today. And just as a reminder, the museum's live streams are free, but if you'd like to support us in delivering programs just like these, please click on the link in the comments or in the description. Now, feel free to use the chat today to say hello. We are live. Let us know where you're tuning in from. Let us know if you've ever been to the Intrepid Museum before. And of course, if you've got any questions, you can put them in there too. Now, our museum, the Intrepid Sea, Air and Space Museum, is located in a historic World War II era aircraft carrier that also served during the Cold War and the Vietnam War. And we have a lot of really cool airplanes and helicopters and a submarine. But often when people come, they wonder, okay, I get why you're a sea museum and why you're an air museum. You're an aircraft carrier. That makes sense. Why are you also a space museum? Well, believe it or not, a long time ago, way back in the 1960s, the Intrepid served as a prime recovery vessel for picking up NASA's space capsules. So way back when NASA was just getting started and, they were launching these space capsules up on rockets, eventually they'd have to come back down again and they would land in the ocean. Now, of course, the capsules and the astronauts inside of them needed to be picked up again. We couldn't just leave them floating in the ocean. So the Intrepid was able to pick up a few of those astronauts and capsules and complete those missions. And that is why actually we have this really, really cool connection to space and also why we like to talk a lot about space too. So today we are going to talk a bit about space, a bit about planets in space specifically, but with an eye towards what is needed to support life and specifically human life. And we are going to be using a really cool website called Solar System Scope. So let's start our journey together and take a look. All right, everyone. So first of all, what are we looking at here? Let me know in the chat if you happen to know. There might be a clue on screen. It has a title on it there. But let me know what we're looking at here. What is this beautiful blue marble? What would we call this? This is our home, of course, right? This is the Earth. This is where we live. And it's also where we are right now, right here in the universe. And also right now, this happens to be the only place that we have ever found life as we know it in all of outer space so far. So I do like to start here to talk about just why Earth is so very special. Planet Earth is able to keep us alive for a few very important reasons. So out there in the chat, let me know if you can think of any reasons why. What are some things that we have here on Earth that help to keep us alive? And maybe what are some things that we need in order to survive? What are these basic things that are essential to support human life here? The first one, pretty easy to spot when we're first looking at this here, this beautiful blue marble. It's that blue color, right? So all that blue that we see on the planet there, it's water. So the water all across our planet is essential. We need liquid water. Our bodies are primarily made up of water. We need water to drink and survive. So that water is essential. That is something that is not easily found throughout the universe. Another thing that we need in order to survive is, of course, the thing that we need to breathe. When you are out in space, we don't have this thing necessarily around us in order to be able to breathe. We need oxygen. We need the oxygen that is surrounding us here on Earth and being held in by something else, the atmosphere. So if you notice this beautiful light blue line all around the outside of our blue marble here, that light blue line around it, that's our atmosphere right there. It's made up of a number of different gases, and that, again, helps us to have air pressure as well. That's another thing that's important. People don't necessarily think about that one first off the bat there, but if we didn't have air pressure, well, none of our oxygen would be around us anymore. And also, of course, we need to be able to stay here on Earth too. We don't want to be floating out into the universe there. Gravity is helpful for that as well. It also, though, helps to maintain our temperatures a bit. We want our temperatures within a very comfortable range, we could say, for humans. We want it to be in an acceptable range for us to survive so that we're not fried, we're not frozen, and, we can live a comfortable, our comfortable lives. Now, of course, it does get cold outside sometimes. It does get very hot outside sometimes as the seasons change. But for the most part, we can bundle up or we can, jump in a pool or something to cool off. So as long as it's not extreme temperatures, that's pretty good. So whenever we're looking for life, or rather for places that we could support life in other places in the universe, that's another thing we want to look for. We don't want it to get too hot or too cold. We want it to be just right. So again, we need to recap: air to breathe, so oxygen more specifically. We need something to keep that air close to the planet, to keep it contained so it doesn't just escape out into space. So again, our atmosphere. We need water to survive, to keep our bodies healthy. And also we need comfortable temperatures. We do not want to be so close to the sun that we burn up. We don't want to be so far away that we freeze. Again, that Goldilocks zone, right? Not too hot, not too cold. So those are the key things. So with all of that in mind, everyone, do you think that there's anywhere else within our neighborhood of the solar system that we could live? And if humans can't live there, what sort of life might already be living there? So let's take a look at our solar system, shall we? So we know the planets, of course, that go around the sun. All right, we're going to be taking a little bit of a tour for them today. They rotate in orbit around that center point, first of all. That center point of our solar system, of course, right here is the sun. The sun is a very, very important thing. It is our closest neighboring star. And scientists believe that a long time ago, though, really just how the whole solar system got formed in the first place, they thought there was this big cloud of dust that was floating around in outer space. And then something happened. Something collided with it. Maybe like another cloud, another big cloud of dust flew through it. And then it all began to combine. So pieces of dust started smashing into each other, making bigger pieces of dust, basically, kind of like how, in a snowstorm, you might have all these big snowflakes that are coming in, crashing into each other and maybe combining and making bigger snowflakes. So eventually all of that dust kind of settled into the middle of this cloud. And that was the beginning of our star, the sun. And as it got bigger and more things collided with those dust pieces, it started to pull more and more things towards it and around it. And so a bit further away from that dust ball, smaller clumps of this dust started to form. And then these eventually became our planets. Now, these collisions, they generate a lot of energy, everyone. And so imagine, a bunch of little explosions on impact every time. So the clumps that are closer to the sun, well, a lot of these planets formed pretty quickly. And a lot of that gas that resulted from those collisions got whipped away. So the 4 closest planets to the sun happen to be rocky planets, whereas the gases stayed and were more kind of collected near the back of the solar system. And those are our gas planets. And that, my friends, is our solar system in a nutshell. Now, again, let's start off by talking about the center of our solar system, the sun. Now, the sun is a pretty massive star. And let me ask you a question, everyone. You can put your answer in the chat for me. What percentage, so this is going to be a number between 1 and 100, what percentage of the solar system's mass do you think the sun is? What percentage? Now, again, when I say mass now, okay, I mean everything. So every planet, everything on each planet, every asteroid, every moon, every little rock, and every person, every house, and everything that you own in your house, your clothes, your gadgets, everything here on Earth, all of this stuff is mass. So what percentage of the entire solar system do you think the sun makes up? So go ahead and give me a number between 1 and 100. 1% would be just the teeniest, tiniest, itty bitty little baby amount. And 100 would be everything. There's nothing else in the solar system. It's just the sun. There's nothing else. Any guesses? All right. So believe it or not, everyone, the answer is 99.86. So our massive sun makes up 99.86% of all the mass of all of the stuff in the solar system. That's big. That is really, really, really big. That's almost everything. And it's also really bright too, right? So researchers once thought that it was just another insignificant star in our Milky Way galaxy, but it's actually now considered to be brighter than about 85% of the other stars in our galaxy. So that's also important to consider if we're going to be looking for other Earth-like planets outside of our solar system, which is something called an exoplanet. Now, because of its giant mass, it attracts other things towards it and around it. And of course, it has the planets that orbit around it too in our solar system. So let's take a look now. I'm going to make this a bit bigger for you. Let's take a look at our first planet in the solar system. All right. So as we, zoom out again, here is our solar system. It is beautiful. There's so much going on here. But our very first planet here, it's hiding behind the sun. Oh, zoom in here. There he is. All right. So our very first planet here is Mercury. Now, if you take a closer look at Mercury here, what does this planet look like to you? If you've ever seen some of our other programs, we talk about Mercury quite a bit because one of the missions that we picked up happened to be named for Mercury. But does this planet look like anything else? Maybe even something that you can see here from Earth? A lot of people say it kind of looks like our moon. And I agree. I think it does. So everyone, this is Mercury. It's named after the Roman messenger god, Mercury, kind of like their mailman. It is the closest planet to the sun. And because the sun makes all of this stuff swirl around it all the time, a lot of that stuff happens to crash into Mercury. So it's also the most cratered planet. So you can see all those big dents and holes in it. Those are craters. And that's what happens. So here's another question for you, everyone. The Earth takes 365 days to go around the sun, right? That's 1 year for us. Now, keeping in mind that the sun's mass attracts things the closer they are, and it makes them move a little bit faster, how many days do you think it takes for Mercury, our first planet, to go around the sun? Pop it in the chat for me if you happen to know, or just take a guess. Give me a number. How many days do you think is 1 year on Mercury? All right. And again, its speed might have something to do with how it got its name, too, from that Roman messenger god. He was very fast. You see him a lot with wings on his hats and on his shoes. So generally, now, again, the further you go out, the longer it's going to take a planet to go around the sun because it's going to get a bit slower. So if Earth, not the first planet, so you were in a little bit, if Earth takes 365 days, it'd probably be a little less than that, a little faster. So the answer, everyone, is it takes 88 days for Mercury to rotate around the sun. That is about a quarter of the time that it takes Earth. So that's about 3 months in our time. Now, Mercury doesn't have an atmosphere, you might have noticed. And because of that, it can get up to 800 degrees Fahrenheit on the side closest to the sun. Again, it is the first planet. But it might surprise you to know it can get to negative 400 degrees Fahrenheit on the side away from the sun. So the atmosphere, again, is really helpful to spread around the heat. It helps it to spread around like we have here on Earth. Now, that is really, really essential because, again, we do not want these extreme temperatures. So the atmosphere is something we're going to be looking for if we're looking for a place to live elsewhere. But do you think we can live on Mercury as a result then? Yeah, probably not, right? Those temperatures are really extreme. And it also doesn't have the other things we need like oxygen or water either. So let's keep moving out onto our next planet, everyone. The next one that we are going to be looking at here is Venus. And here she comes. Alrighty, so here is Venus. Very pretty. Venus is known as our sister planet because it's actually similar in size to Earth. It's also the only planet that's named after a female deity. So Venus was the Roman goddess of love. And interestingly enough, it's the only planet that rotates on its axis the opposite direction as us as it goes around the sun. Now, unfortunately, we cannot live on Venus for another reason. Even though Mercury is the closest planet to the sun, Venus is still the hottest. And it's for the same reason that our planet gets warmer each year, unfortunately, greenhouse gases. So there's a lot of carbon dioxide and other greenhouse gases that trap the sun's heat inside of Venus's atmosphere. So that's actually an instance of an atmosphere that's actually going to be making it harder for us to survive. Now, the other issue is that the surface is actually covered in volcanoes, and these volcanoes spew out lots of toxic fumes as well. So Yeah, well, it is very pretty. Look at that. Gorgeous. In fact, it's actually one of the brightest objects in the night sky. You can see it here from Earth, next to the moon, of course. It's not really somewhere that we could live, unfortunately. So, everyone, I want to pause here before we move on and see if we've got any questions before we move on to our next planet, which, spoiler, you've already seen it. You live on it. What is the sun made out of? Oh, great question. So, the sun is actually mostly made out of helium. That's that stuff that, they put into your birthday party balloons. It keeps them floating up in the sky. So, it's about 3/4 helium. And then the rest of it is made up of elements like carbon and iron and neon, which is, the lights, the neon lights that you see in New York City, and oxygen. So all that stuff actually produces a really large amount of heat. Obviously, it's the sun. In fact, the surface temperature, though, of the sun is over 10,000 degrees Fahrenheit. That's almost 6,000 degrees Celsius. But you have to also keep in mind that it doesn't really have a surface per se. It's really just a huge ball of gas. And 99% of all of the power of the sun comes from its smaller core. And then that is surrounded by something called a photosphere. And that's you can imagine it kind of like a very thin atmosphere. But, even though it's got that kind of atmosphere, it's just way, 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 way too hot for us to ever live on the sun. So yes, that is not a place we'll be heading. But good question. All right, any other questions? Why does Venus rotate backwards? Oh, good catch. Yeah, so that's a really great question. Scientists are actually still trying to figure that out. They think that originally it might have actually spun the same way as the rest of the planets, but that maybe it flipped its axis 180 degrees at some point. So basically it's upside down right now, and it looks like it's going the opposite direction. So it just kind of did a little bit of a somersault. Why it flipped? They actually aren't sure. They don't know. They thought it could be just really strong pressures of Venus's atmosphere. Actually, good point. The atmosphere, it's 92 times stronger than what we have here on Earth. And, that with the sun's gravitational pull, it might have moved it. It might have, flipped it. But again, they really don't know. There is another theory, though, that it didn't flip. It actually just eventually slowed down to the point that it just stopped spinning and then just started going the other way. So who knows? Maybe something, came by it and accidentally grabbed it as it was swinging by and spun it the other way. We don't know. It's one of the things we're still trying to figure out. All right, everyone. So our next planet, of course, back to Earth where we started, and where, of course, if you look out your window, I assume you are also on planet Earth right now. Although if you're not, hey, hello. And there's something around Earth I mentioned before that we can't see. I mean, you can kind of see it here, but it's that beautiful light blue layer around it. It's very important to us. If the Earth was an egg, I like to say it's kind of like that thin eggshell all around it. But there's actually something else that is even more invisible that we don't even think about, and the inside core of our Earth. See if we can take a look here. Here we go. The inside core of our Earth is made out of metal, molten hot iron, and nickel, and it creates something called a magnetic field all around our planet. And that's important because it helps to protect us from particles that are shooting out from the sun. So as these particles start to come rushing towards our planet from the sun, they can be really dangerous. They can, even strip away parts of our atmosphere. Of course, the atmosphere we need to survive. And if they get through, well, that's why they tell you to wear sunscreen, right? It can hit our bodies. It can actually get into your DNA, cause mutations and serious health problems, really, for all living things too, not just humans. So that magnetic field causes those particles to bounce off and shoot away in other directions into space. Now, sometimes they do get through that magnetic sphere, and sometimes they do interact with our atmosphere. And when that happens, it can cause some kind of neat things that happen in the sky. Does anyone happen to know what we call that? Tell me in the chat if you know. What is it? What do we call it when the ionized particles from the sun, they kind of interact with our atmosphere? Sometimes it can cause some really cool colors to appear in the sky. It often happens around the north or the south poles. Usually it's kind of greens or purples. Yes, Niku FIT, excellent. Auroras, yes. So the aurora borealis, or the northern and southern lights, that is what happens when those particles actually slip through the atmosphere. Very good. Now, the Earth is located, everyone, in a very specific spot in our solar system, a very special spot, you might notice. Again, we were talking about we didn't want it to be too hot, too cold. It's located in a very special place. It's about 93 million miles from the sun. It's within this very special zone that I mentioned where water can actually exist as a liquid on the surface of a rocky planet. We call this zone the habitable zone. Okay, or the Goldilocks Zone. I mentioned that before. Because again, not too hot, not too cold for human life. Now, every star actually does have a Goldilocks zone, a habitable zone. And it can be further out or closer in, depending on the brightness of the star. So it does vary in each particular system. But the Earth is in this very special spot. So that's important. If we're looking for other exoplanets and other systems, we want it to be in a habitable zone. And it won't always be the same distance. Now, the Earth is also the first planet from the sun that has a moon. So let's check out that moon. Again, might look a little familiar. Kind of. We were looking at Mercury before. Look at that. It really does look a lot similar, doesn't it? So here's a question about the moon, everyone. Have you ever noticed when you look up into the night sky and you see the moon, you ever notice it always kind of looks the same? I mean, obviously, you see it gets smaller or bigger depending on the shadow on it, right? But have you ever noticed that the craters and everything, it kind of looks the same, right? But the moon spins around, right? It spins around the Earth, right? So why do we always maybe just see one side of the moon? Well, that is a thing. The moon is something called tidally locked. And that means that the same side is always going to be facing towards the Earth. So when we rotate away from it during the day, it's still facing us on one side. And then when we rotate towards it at night, it's still there facing us. It does orbit on its own path, but remember, it's still going around us and we're moving too. So it's all happening at the same time. But it's for that reason that we only ever see one side of it. So if you imagine that, you're facing your friend and you're both turning around at the exact same rate, when you both come back around again, you're both going to see each other's faces, but you actually see the other side too. All right, now the next planet, everyone, is of course something that's been in the news quite a bit. Heading over to Mars now. Mars is a planet getting a lot of press these days, obviously. We just landed our Perseverance rover on the surface earlier this year. So excited. We're actually going to be getting a full-size model of the Perseverance rover at the Intrepid Museum, by the way, in the coming months. So come by, check that out in February through June, I believe. But there's been a lot of talk as to whether Mars maybe once had life a long time ago, and also whether humans could maybe live there in the future. So while NASA does have plans to put astronauts on Mars within the next few decades, is this going to be the kind of place that we could actually live long term? Well, let's take a look. Again, here's Mars. It's a red planet. It got its name because it looks like a big, angry red eye. So they named it after the Roman god of war. Does anyone happen to know, let me know in the chat if you do, why Mars is red? Anyone know why Mars is red? Take a guess. Let me know. We've obviously been very lucky to have a number of pictures of Mars because it is so close to us. And that was really helpful for Perseverance while it was landing as well. So we knew what the terrain was going to look like. If, you look around at these surface features, there's obviously some rocks and things going on. We know that Mars has volcanoes and canyons, and it's also got the highest mountain system in the solar system, believe it or not. That is actually going to be larger than Mount Everest on there, believe it or not. I see in the chat oxidized iron. That's the reason for the color. Yeah. So the surface of Mars is red because it's covered in iron oxide. So basically rust. It's the same thing that would happen if you left your bike out in the rain. It would start to get a little bit rusty. little brown, a little gross. So that iron oxide reaction, that is when the iron gets a little air with it, I guess you could say. It's oxidized iron. Iron oxide dust. Yes, Vashton, exactly. And so that is why Mars looks red. That is the surface of Mars. Now, the reason I brought up this magnetic field before is because looking at Mars is kind of like a science experiment. When we look at Mars, we can actually see what might eventually maybe happen to our planet. So, Mars doesn't have a magnetic sphere around it anymore, but there is evidence that it once might have had one, which means that Mars may have also maybe had a very thick atmosphere around it too. The plot thickens, right? Our past Mars rovers have seen that they even think that it might have had oceans, entire oceans of liquid water, and even weather at one point, too. So that's why Perseverance is so, so cool. And we are watching it so closely. Its primary mission is to look into this more specifically. So, really searching for possible signs of past life and exploring what they believe was once an ancient river delta and a lake around Jezero Crater, where it is. Now, of course, we do not know for a fact, for sure, that there is life on Mars. And, all of this also doesn't mean that anything even used to live there. It just means that Mars had many of the things that we need to support life. It still actually does have an atmosphere, but it's just much, much, much thinner than ours right now. It is 95% carbon dioxide, though. So it doesn't do a great job to shield its surface from those solar particles or, keep liquid water in place. And also, while the temperatures in the summertime actually get to about 70 degrees Fahrenheit, that's about 20 degrees Celsius during the day, which is very, very nice and comfortable. At night, it can get down to 200 degrees below 0 Fahrenheit or about negative 130 Celsius. So cold. But all that said, it is still really fascinating to us. And we certainly want to know more about this place and, see if maybe there used to be living things at one point there too. All right. So next up on our tour of the solar system, everyone, of course, we've got our asteroid belt. And then, of course, we come to Jupiter. Jupiter, there it is. Oh. All right. Looks like I might have just accidentally lost my screen. Let's start that back up again, everyone. Got so excited to be going to Jupiter, couldn't even wait. All right, as it's loading up here. Let's get going back here. There we go. All right. Let me just change a couple of these settings here. As I'm doing this, everyone, actually, too, I'll let you know about this website that I'm using. It's called Solar System Scope, and you can check it out. It's online, solarsystemscope.com. And it's a really great way to explore everything that's going on. I'm just removing some of these extra little settings here. All right. So here's Jupiter. Let's pull up Jupiter for you. So Jupiter, everyone, again, thanks for bearing with me. The king of the planets. And here's a question about Jupiter. Can anyone tell me what that big red spot is? Let me know in the chat if you happen to know. What is that big red spot on Jupiter? A big red spot swirling around. Anyone happen to know? Yes, it is a giant storm. So Jupiter has been impacted by comets, but the red spot in the storm has actually been raging on for hundreds of years. And ever since scientists have been observing it, they've noticed that it's actually starting to go away. It has decreased in its size just a bit. So Jupiter is what we call a gas giant. All right, it is the largest planet in the solar system, and it has a ton of moons. In fact, it has 79 of them. And we're going to talk about a few of them in just a bit. But something else interesting to note about Jupiter is that it spins faster on its axis than any other planet. And because of that, there's very, very high winds. And that's why you see those swirling bands of color. Now, Jupiter also actually has a huge magnetic field too. But there's no surface. That's the big draw, or that's the big catch really about Jupiter, there is no surface to it. So the magnetic field is caused by its largely liquid hydrogen mantle, but otherwise it's predominantly just gas. That's it, just gas. So Jupiter is also really cold. It's negative 180 degrees Fahrenheit. So not to mention, very, very cold. Definitely bring your parka out there. And it's pretty violent with all of these storms too. So again, don't think we'd want to live there either. So we can move on here, pass on that one. Let's head up to Saturn. Saturn is on its way. Here we go. So Saturn, of course, is probably the most notable one. I wore my Saturn earrings for you all today, actually. You can see them. Probably the most notable. Again, it's got those rings. Look at those beautiful rings. And, when we look at it, you can actually see just how thin those rings are. Look at it from the side. They all but disappear there. Isn't that something? So these rings here are really just a bunch of dust and rocks and ice and debris. It's just floating around Saturn. And it's actually a really good depiction of what the solar system looked like while it was forming, just kind of on a micro scale. If you imagine the main planet of Saturn as the sun and then all the other stuff flying around it, that's basically what the solar system looked like to start off. Now, did you know Saturn has even more moons than Jupiter? That is true. It has 82 currently identified moons, but again, there's a lot of stuff swirling around Saturn here. They possibly have 150 more that they're looking at and trying to determine, is that actually a moon or is it just other stuff flying around? So it is also Saturn, a gas giant, just like Jupiter. It also doesn't really have a surface. It's primarily gas and it's very, very cold. Again, about 200 degrees below zero. And it takes a long time to orbit around the sun. It takes 29 years. 29 years for 1 year of our Earth's time. So the winds on Saturn also move at 5 times as fast as those on Jupiter even, which I mentioned also moved really, really fast. So yeah, again, you don't really have a surface, kind of cold, and just torrential windstorm all the time. I don't think we could comfortably live on Saturn either, unfortunately. Yeah. So moving out here, let's move on a little bit further out into our solar system. The next planet, everyone here, Uranus. And here we go. Now, as we zoom into Uranus here, you might notice something here that might surprise you. Look at this. It also has a ring around it. Did you know that? In fact, all 4 gas and ice giant planets have rings. They're just all different sizes. And, a lot of people actually don't know that. Look at that. But if you take a look at it, actually, if you look at this one, you might notice that it looks a little bit different. And in fact, it's a little strange because we're kind of flying around out here in space. But the ring itself around Uranus is configured slightly different than Saturn. It almost looks like it's knocked on its side in reality compared to Saturn. So Uranus is actually at a 97-degree tilt on its side. And we don't really know for sure why, but scientists think that maybe something really big, even like a planet-sized thing, hit it and knocked it onto its side like that a long time ago. And now it's the only planet that rotates on its axis in this way. So it is definitely very special in that regard. Now, what is cool about Uranus is that because of its chemical composition and its pressure, scientists believe that it actually rains diamonds there. You heard me right. It rains diamonds on Uranus. And there's even oceans, they say, of liquid diamonds. I don't really know what that would even look like, liquid diamonds. But before you pack your bags, everyone, you got to know it is, first of all, extremely far away. It is very, very cold, negative 350 degrees Fahrenheit, the coldest planet in the solar system, which is, of course, very bad for us humans. And it also would take 84 years to orbit the sun. So again, you're noticing a trend here. The further out we go into the solar system, the slower those planets are going to be moving. Now, we have one last major planet, of course, to look at. If you were in school, when I was in school, you learned that the last one was actually one past this, but we are actually going to go visit what is currently the furthest one away. This is Neptune, even further away there. But again, beautiful blue planet. And if you take a look, you will also notice, let's see if I can find it. There it is. You'll also notice right here, it has another storm on it. This is what they call the Great Blue Spot, as opposed to the red one on Jupiter. Now, of course, it was named Neptune after the Roman god of the sea because of its blue color, right? Like the ocean. And it's actually so far from the sun that since it was discovered, it has only made just over one orbit around the sun. It was discovered in 1846, and it takes 165 years for Neptune to go around the sun. So you might not have a birthday on Neptune, honestly. Now, Neptune was discovered in a very interesting way, actually. A long time ago, scientists were observing Uranus and they realized that it wasn't moving how they expected to. Now, again, Uranus is the one we just looked at. And the only explanation that they had was that there was something else, maybe planet-sized even, messing with its orbit. And again, remember, we're looking at this here from Earth, so it's far away. So they did a lot of math, believe it or not, and they decided, okay, based on our calculations, it seems like there should be a planet right about here. And then when they looked through a telescope at that spot, sure enough, they found Neptune right where they were expecting it to be, and that's how it was discovered. So everyone, before we move on, I want to see if we have any other questions. Any other questions before we move on? Is there water on Mars? So no, we haven't found any liquid water on Mars yet, but there has been evidence that there might have been at one point. They did find signs of water in rock layers and even deposits of sediment on the surface that contain minerals that can be found in water. And the surface kind of looks like there might have even been like huge floods there billions of years ago that collected in these giant canyons and craters. There's also signs of frozen water, possibly near the south pole of Mars too. So that's why it's just so exciting that we have gone in there with the Perseverance rover. We are more ready than ever now to look into this and collect samples and see what is up with the water situation out there. Great question. Any others? How big are Saturn's rings? So we actually saw that they're pretty thin from the side, right? They are only a half mile thick, believe it or not. It's really just how wide they stretch out around Saturn that is so magnificent and that we really can see from our telescopes. They stretch on for almost 200,000 miles, believe it or not. And again, it's just a lot of dust and ice. So that actually is able to reflect the light of the sun really well. And that's what makes them shine and sparkle so brightly too. But yeah, it's kind of a trick of the eye in a way. It's very, very thin from the side, but very, very wide, 200,000 miles wide, believe it or not. All right, now many of you here today may have learned, I mentioned this earlier, that there are 8 planets and that Pluto is not actually a full-fledged planet in our solar system. Peter in the chat even said, "What about you, Pluto?" Exactly. But believe it or not, yes, when I was a kid, and maybe some of your grown-ups were kids, and maybe some of you grown-ups out there now too, Pluto was still definitely considered one of our main planets. So does anyone know what Pluto is now classified as? Tell me in the chat if you do. What is Pluto now classified as? And I'm going to get us out there to Pluto so we can take a look. Here we go. Flying out to Pluto. And thanks for bearing with me, everyone, with my beautiful green screen. My, I don't know, something happened and it didn't want to do it anymore. All right, so we see dwarf planet in the chat, planetoid. Nice. All right. So everyone, yeah, let's look at Pluto here. Pluto is super, super far away. Like I said, it used to be a planet, or classified as a planet, but now it's classified as something else. It is classified as, yes, Niku FIT, dwarf planet. Now, why is that? Why did it change its criteria? Well, there are 3 criteria to make you a planet. So anyone out there, let me know if you happen to be a planet. You have to, A, orbit the sun. So far, we're doing that, right? B, you have to have a round shape. I mean, we've all been stuck at home for a while, so maybe you can make that argument. And you also have to clear your orbital path. And that means that you, if you're going around the sun, there can't be anything else around you close by that doesn't also orbit you. Now, I know many of us might think that the world revolves around us, but it does not. So, for instance, the moon orbits around Earth, also orbits around the sun. But the moon, because it's orbiting around Earth, it's not a planet. It's not its own planet. It is a moon of Earth. But when it comes to Pluto, everyone, while it does have 5 known moons, they do orbit around Pluto, but they almost actually also orbit around each other equally. So because of all of that, because it doesn't entirely clear its orbital path, it got demoted to a dwarf planet. If we let it be a full planet, we'd have to go and make all the other dwarf planets full planets too, because that's the classification. So it is a little bit more specific, but Pluto is still really, really interesting. It's very icy, as you can see. And of course, it's got, its cute little heart shape on it. We love Pluto. It's a cute little heart-shaped ice cap. But like Uranus, Pluto is actually also considered to be lying on its side, believe it or not. It's at 120-degree tilt, which means that the seasons are very extreme. Again, we've got these very strong seasons. In fact, during the solstices, so that's the longest and the shortest day of Pluto's year, a quarter of the planet is in constant light or constant darkness. A quarter of the planet. So because of that, it also means it's extremely cold. It's negative 375 degrees Fahrenheit on that cold side. And it takes 248 years for it to fully orbit the sun. That is a long, long time. So that is the planets. Some of the restrictions, of course, that humans might face living on our other planets. But why limit our search for habitable planets to just human life, right? Life on Earth takes on some really, really wild and really varied forms. And might there be a place that we can find some life elsewhere in outer space? Because we may need to stop looking for life on planets specifically and maybe start looking at other things, maybe like moons, right? So we can actually explore some moons too. Whoops. So let's take a look back at Jupiter, specifically one of Jupiter's moons. All right, we are going to be looking here at Europa. Let's check this one out. So Europa is one of the largest moons of Jupiter, and it kind of, when you're looking at it, might look just like a lifeless ice ball, but you might notice something else kind of interesting about it. Do you notice these scratches on the surface, right? So these are actually cracks in the ice underneath this frozen and cracked up exterior here. Europa actually has oceans. It's a secret, but oceans, liquid water, right? And actually potentially more water than there even is here on Earth. And water bodes well for life. So the Hubble Space Telescope actually spotted geysers, okay? These cryovolcanoes is what they call them, while we were looking at Europa. And these geysers aren't things like Old Faithful here on Earth. Our geysers here on Earth are, hot, steamy water, but rather these are the opposite. These are cold volcanoes. These eject water and ice off the planet, off about 125 miles actually off the surface of the icy moon from this icy crust. So it has an atmosphere and it has water. So, it's a good question. Could there be life there? Maybe. It wouldn't necessarily look like us per se, but yeah, it's got some of the things necessary for life as we know it, at least out there. So let's look at some other moons. Here's another one we can look at in Saturn. All right, we're going to be looking at Enceladus. There it is. So again, you notice a trend here. These ones are pretty far away. They look pretty cold. Saturn actually does have two moons that might have life, but Enceladus is the first one here. And it's also got these plumes that come out of the surface of it at its south pole as well. So these cryogeysers. And in fact, in 2005, we sent another orbiter, the Cassini orbiter, and it was able to take a closer look at these massive geysers of water shooting out from the south pole. And it even flew directly through the plumes and was able to detect organic molecules. So not life, but the things that life needs, things like carbon. So again, this does have an atmosphere and an icy crust with water under it. So another one that we definitely want to keep our eye on. Now, there is another moon of Saturn. Let's see if we can find it here. There it is. Ooh, right down there. Great. So this is Titan. Titan is perhaps the most interesting of all. So Titan is Saturn's largest moon. It's actually the second largest in the solar system. But that isn't the only thing that makes it really special. Titan has an atmosphere, and it is much thicker than Earth's, and it has oceans, and it has terrain. So it certainly might have life, everyone, but for sure it is not going to be life like we have on Earth, because all of those things that I just mentioned are made mostly out of methane which is very, very, very toxic to humans. So the Cassini orbiter used infrared imaging to look through these clouds that you see here on it. And they spotted a world with, again, rivers and lakes and these seas of liquid methane and even evidence of weather like rain and well, but again, it's all liquid methane. So I don't know if you'd want to have liquid methane raining down on you. But we do know that here on Earth, anyway, deep, deep in our oceans, we actually have vents that pump out methane under the water, right? And there are actually organisms that that kind of hover around these little vents, and they eat it up. They love it. They thrive on that methane. They feast on it. So if life has been able to evolve to eat methane here on Earth, maybe something has evolved to do the same out there on Titan. I mean, it would be a bountiful feast for sure. It's all over the place, but we just don't know. But it is really, really interesting. Now, with the advent of the Hubble Space Telescope, of course, we've been able to look more closely at our solar system and learn more. Look at this. We are going way far out here. And we've been able to travel outside of our solar system, even and look at places beyond even our Milky Way galaxy, which is what you are looking at right here. Now, we can't, of course, take a picture of our own galaxy because we are in it and we haven't traveled anywhere near that far yet. But we can take pictures of other galaxies nearby. We can look at their stars. We can see if we can find other things called exoplanets, right? Exosolar planets. They're outside of our solar system. Now, these are planets that orbit another star. So not the sun, but another star that is maybe like the sun. And there's one that we know of for sure, for instance, called Fomalhaut b that we've been able to take a very basic picture of, at least. It's very, very far away. And there's another system that we know about called the TRAPPIST system, which actually has 4 planets in it in its Goldilocks zone away from its star. So we think actually they might be ocean worlds. We don't know for sure, but possibly part ice and part liquid water. Kind of a lot like Earth, has an atmosphere. So there could be life on those planets. But again, we just don't know. So we are still exploring, but it is a really, really great place to start. And then just thinking about all these things. So as of December 1st, 2021, there are 4,878 confirmed exoplanets. Again, these are planets outside of our solar system, plus an additional almost 5,000 candidates to be confirmed from a variety of other missions. And then of those that we've confirmed, scientists think that there are at least 60 of them that might be habitable based on some of those things that we talked about today. So we're definitely only scratching the surface of these planets. There's still a lot more that we don't know. But with the James Webb Telescope going up, we are going to be able to see so many amazing things. We are going to get a much better look into the depths of our universe. We are going to start answering so many questions and just get one step closer, maybe a lot of steps closer to finding life out there, maybe. But of course, with every question we answer, we have so many more that pop up, and only time will tell. So everyone, that concludes our program, Biome Away from Home today. But I want to see if we have any last questions before we wrap up. So I'm in my green void today. Have we ever visited an exoplanet? No, we haven't. We only have an idea about these distant planets based on our data from telescopes that, they tell us about their size and their proximity to the star. But that is actually really important to point out. Let's say that we, decided to abandon Earth for whatever reason, and we decided to travel to one of those exoplanets that's within a habitable zone. You also have to think about the time that it would take for us to even travel there. We are so tiny in our own solar system, let alone another one to even travel to it, right? You think that exoplanets, a habitable one, right? Maybe there might be like 2 within maybe 10 light years away. Again, still a big might. We don't know. But if you think about it, a light year, it's the distance that it takes light to travel in 1 year. So that's actually about 60 trillion miles away. And that light is moving about 700 million miles per hour. So our spacecraft goes fast, Not that fast. Apollo 10 actually set the record, I believe, for the highest speed of a manned vehicle. It was close to 25,000 miles an hour. But even at that speed, it would still take you, I don't, like almost 300,000 years to go 10 light years away to even just check out that exoplanet. So you wouldn't survive the trip, unfortunately. We need to figure out first how to travel at light speed or faster at this point, just in order to even consider something like that. But who knows? Like, let's not rule it out, right? It might happen someday. It might be possible. It sounds like it'd be a lot of fun. But that's the first thing that we need to figure out is how to actually even survive the trip, assuming everything else goes well. All right. Any others? How many exoplanets are there? We don't know. Again, right now we have just over almost 5,000 confirmed exoplanets. It doesn't mean those are habitable though. But if you want to consider how many potential exoplanets might be habitable, even very, very, very far away, you can kind of think of it like this. You've got the solar system, like ours. It's based around the sun, right? The sun is a star. So scientists are discovering new stars every day. So far, they've identified over 70 sextillion known stars and counting. That's a lot. So to understand that a bit better, there's this idea that if you took every grain of sand on every beach here on Earth, every tiny little piece, every playground, every crack in a sidewalk, every tiny little grain, and you added them all up, there would actually still be more stars than even that. So, you might suggest that maybe there could be at least one exoplanet in each of those stars' orbits that's maybe in a habitable zone, not too hot, not too cold. So that gives you an idea, especially if there's more than one. There's a lot. There's a lot of possibilities. And it really is mind-boggling to think about, and really makes you wonder, though, if maybe there's even another Earth out there, right? Maybe even hundreds or thousands of them even. Nobody knows. Amazing. So everyone, on that note, thank you so much for joining us today. I would like to point out that the website that I use today, that you can use to check out the solar system and take a look around, it is called solarsystemscope.com. So definitely check that out, solarsystemscope.com. You will be able to kind of take your own little tour of the solar system and explore even the stars too. It is confined to our our solar system and Milky Way. You can't go too much further, but it is a really great thing and lots of resources there to learn about even the insides of the planets and stuff like that and all their moons. So once again, if you have any questions about our programs, you can reach out to us through our website, intrepidmuseum.org, or also through social media. Be sure to follow or subscribe to this channel. Visit our website for our upcoming programs. And if you enjoyed this or any of our past programs, we'd love your feedback. There is a link in the chat that we encourage you to click on to answer a few questions that'll help us to plan for future sessions. Now, our next family program will be next week, Thursday at 3 p.m., and it'll be Holidays at Sea. So we're going to talk about some of the ways that sailors came together to celebrate and have fun during the winter holiday season while they were out at sea for 6 to 9 months at a time, and also some of the holiday traditions that kept them entertained. So once again, that's coming up next week on Thursday at 3 p.m. Finally, I would like to invite you to join us tonight in just about an hour for our virtual astronomy live event with Kerbal Space Academy. This is a free online event that will today explore the DART mission. So this is a test for planetary defense against asteroids. And basically, they are literally just going to be ramming a spacecraft into an asteroid to test to see if they can knock it off its orbit. So that'll hopefully maybe help us out in the future should anything big and scary come at us. We're going to have mission manager Scott Bellamy on to talk about the mission and what the future holds for it. And then also be sure to tune in beforehand at 5 p.m. for our pre-show. I'm going to be talking about some of the most hazardous asteroids in our neighborhood and some role-playing exercises, you heard me right, that scientists and emergency personnel go through to prepare for the worst. So once again, that is tonight in just about an hour. Join us at 5 for the pre-show and 5:30 for the main event. And you can register for free in advance via our website, intrepidmuseum.org. One last reminder, everyone, our museum is back open to the public 7 days a week from 10 to 5 p.m. So we would love for you to come by and check us out, visit some of the cool things we have on display, and learn a bit more about our cool space history. And once again, thank you so much for joining us today. Hopefully, we will see you on for another upcoming virtual Intrepid adventure. Happy holidays, and I'll see you next time.